Discharge washing is a chemical washing technique that removes color from selected areas of dyed fabric. The chemistries used for discharge washing are either strong oxidizers like potassium permanganate or reducing agents like sodium hypochlorite. Ozone processes, which are new to the industry, may offer a clean and simple method for color discharge. Some popular effects achieved by wet discharge include acid wash, moon wash, fog wash, marble wash, ice frosted, snow wash, electric wash, and galactic wash. Both chemical and physical systems can be used to discharge color, and they can be used as a single standalone process or in various combinations to achieve unique effects. These effects can be placed all over the garment or localized in selected areas. They can be very subtle, slightly less subtle, or remove dye stuff completely from a fabric for the most dramatic effect. Because of its chemical nature, indigo dye is easily discharged. Effects are simple to achieve because the dye stuff is only on the surface of the fiber and yarns, making it easy to remove. Potassium permanganate is an extremely effective discharge. When it's applied to fabric, the fabric turns purplish brown, so you can tell exactly where the chemistry has been applied. And when processing is complete, it leaves treated areas completely white. Potassium permanganate is available in liquid, powder, or pellet form. Typically, it's applied to dry fabric. However, in some processes, the garment is wet but fully extracted before the chemistry is applied. Treating fabric when it's dry results in a whiter discharge. Potassium permanganate can be applied by brushing or spraying, both of which create a large or distinct area of discharge. For example, it can be applied to the thighs and seat of the pants to give an aged effect. With brushing, some type of form or mannequin is needed to hold the garment. Jeans, jackets, and other denim items can easily be treated in this manner. Brushing requires some skill to be effective. First, a paintbrush is dipped into a potassium permanganate solution in a paint tray. The excess is brushed onto a fabric blotting pad to remove any excess liquid. Then the solution is brushed onto the denim surface where the discharge is desired. If the potassium permanganate saturates the jeans or is improperly applied, overly white spots or blotchiness can occur. A significant amount of brushing is needed to cover the desired area, so hand brushing is most often used to treat very specific areas. For large areas, the preferred treatment method is spraying. As with hand brushing, considerable experience and skill are needed for effective spraying. In addition, the garment is usually placed in a booth designed for spray finishing. The garment hangs on a mannequin while the operator sprays it. Water cascades down the back of the booth behind the garment to capture any spray not directed onto the garment. For novel effects, potassium permanganate can be applied to dry fabric that is tied or restricted so that only certain portions of it are exposed to the chemistry. The process is similar to tie-dyeing. The effect on this pair of jeans was named flowers. These jeans have a watermark effect. Brushing and spraying are just two application techniques for wet discharge. Another option is to treat the garment in a garment washing machine. This produces an all-over effect on the fabric. A good example of this type of treatment is the acid-washed effect. Acid wash is actually a misnomer for this well-known process because it uses no acid. Typically, the discharging agent is either sodium hypochlorite or potassium permanganate. A basic acid wash procedure includes preparing the garments, preparing the machine, performing the discharge procedure, running the reduction bath or neutralization, top brightening, softening, and tumble drying. To prepare jeans for acid washing, they are usually first desized in a separate machine. It's also important to run them through an abrasion cycle, such as an enzyme treatment, to give some variation to the surface of the fabric. If no abrasion is performed prior to acid washing, the resulting effect will look flat. Finally, the jeans must be uniformly extracted to the lowest possible moisture level. Once they've been extracted, they are moved to a separate acid washing machine. To prepare the garment machine for acid washing, it first must be drained so that no water is left in the drum. Then the drum holes are covered with a plastic liner. The liner keeps the potassium permanganate-soaked stones used in the process from falling through the holes in the drum. Typically, pumice stones are used, weighed at a ratio of 2:1 to dry garment weight. Then the stones are soaked for 2 hours in enough potassium permanganate solution to just cover the top of the stones. The concentration of the potassium permanganate solution can be altered depending on how much discharge is desired. Sodium hypochlorite can also be used instead of the potassium permanganate. Once the stones have been soaked and drained sufficiently, they're placed into the dry machine and tumbled for 5 minutes with white dummy fabric. This removes any excess solution from the stones. The dummy fabric is then removed and replaced with the garments to be processed. The garments are tumbled at high speed with reversal for approximately 15 minutes. Both speed and time may need to be adjusted slightly depending on the machine. Once the process is complete, the garments are removed immediately to avoid creating hot spots or areas of complete color discharge in the fabric. The stones are separated from the garments, with care taken to ensure that all the stones are removed. The garments are then moved to a separate machine where they're rinsed and neutralized. Finally, they're softened as desired and tumbled dry. Another common garment washing process is called electric wash. Electric wash involves the use of permanganate powder and dingers. The process includes preparing the garments, preparing the machine, running the discharge procedure, running the reduction bath or neutralization, top brightening, softening, and tumble drying. As with acid washing, electric wash garments are first prepared and extracted in another machine. Before they're transferred to the garment washing machine, the machine must first be drained so that no water is left in the drum. The holes of the drum are covered with a plastic liner to keep the potassium permanganate powder from falling through the holes in the drum. The weight of the potassium permanganate should be 45 to 50% of the weight of the dry garments. The powder is available in strengths of from 1 to 4%. Once the powder is weighed, it's placed inside the drum on top of the plastic liner. Next, dingers are weighed at a ratio of 2.5 to 1 of dry garments and placed on top of the powder. The next step is to place pre-wet garments on top of the dingers. It's important that the garments touch only the dingers and not the potassium permanganate. Next, the contents of the machine are tumbled with reversal at 30 to 35 RPM for 15 to 20 minutes. As with acid washing, both time and speed may need to be adjusted slightly depending on the machine. Once processed, the garments are removed immediately to avoid creating hot spots in the fabric. The dingers are separated from the garments, and the garments are placed in another machine, rinsed, and neutralized with a reduction bath. Then they're softened and tumbled dry. An alternative to using potassium permanganate powder and dingers is to use potassium permanganate pellets. The process is the same for both, although the pellets are weighed at a 2:1 ratio to the dry weight of the garments. Potassium permanganate pellets are also made at different strengths. For example, the pants on the left were washed with 4% strength pellets, and the pair on the right were washed with 10% strength pellets. As you can see, there's a significant difference in the level of discharge between the two strengths. Bleaching chemistry is similar to discharge washing in that color is reduced or removed, but not necessarily completely. Sodium hypochlorite, which is often used for discharge washing, is also used for bleaching, but in a different concentration, with a different delivery method, and for a different effect. Bleaching alone cannot create localized areas of effect. Localized bleached areas can only occur if the area is first sanded, discharged, or prepared by another method. As with acid washing, bleaching requires an abrasion cycle prior to processing to give some variation to the surface of the fabric. If not, the fabric will look flat. All bleaching uses the same procedures. The only difference is the amount of chemistry used. As you can see, different amounts result in different intensities. A typical bleach-down process includes desizing, abrasion using cellulase enzyme, stones, or both, bleaching, neutralization, top brightening, and softening. In bleaching with sodium hypochlorite, the neutralization step is called an antichlor. The most commonly used chemistry for the antichlor process is hydrogen peroxide. Lacase enzyme is used in denim finishing to break down color. to achieve an effect similar to that achieved by bleaching. The most important difference between the two methods is that lacase enzymes don't require anti-chlor neutralization. This cuts down on the use of water, chemicals, and time. Lacase treatments do require a desizing step with an amylase enzyme and an abrasion cycle prior to the lacase step. The abrasion cycle can use cellulase enzyme, pumice stones, or both. These garments show the effectiveness of lacase enzyme procedures. The pair on the left are loom state, or unprocessed denim. The pair on the right has been treated with lacase enzymes for a bleached effect. A typical lacase enzyme procedure includes desizing and abrading the garments, treating them with lacase enzyme, repeating the lacase enzyme step as needed to remove more color, rinsing, softening, and tumble drying. Ozone gas is a natural part of the Earth's atmosphere. But when ozone is produced by industry or automobile exhaust, it causes air pollution issues. Ozone pollution can cause dyes to oxidize, destroying or changing the color of textiles. This is a particularly troublesome issue in garment shipment and storage. Indigo and sulfur dyes are prone to ozone fading, particularly if backstaining has occurred. With regards to indigo dyed jeans, color discharge is often a desirable effect in denim garments. So it stands to reason that controlled ozone treatments could be used to achieve that effect, since ozone is such a powerful oxidizer and bleaching agent. In ozone treatments, the gas is generated as needed and injected into a closed machine for a period of time. The ozone is used as it's generated. It creates a soft hand and has a washed-down appearance, similar to pigment overdying. Like other chemical treatments for color reduction, the effects of the ozone process are dependent on time and chemical concentrations. And as with other chemical processes, some form of garment abrasion must be included to give character to the fabric. If proven to be commercially effective, ozone treatment has several benefits over other chemical processes. They include reduced water usage, reduced chemical usage, shorter processing time, effective results on most dyestuffs, and the elimination of fabric degradation. Ozone used in garment washing can be environmentally friendly. In some circumstances, water used during the ozone process can be recycled and reused. Currently, ozone treatments are in the developmental stage. After any denim garment wet finishing process, the fabric can be brightened for a cleaner appearance. Top brightening uses sodium perborate in an alkaline bath to create an oxidative scour. The process adds more contrast between the white and lightly colored areas and the darker areas of the garment. Top brightening is a simple procedure and is usually applied just before softener application. A typical procedure uses an alkaline detergent and an optical brightener at around 180 degrees Fahrenheit for 15 minutes. More details on top brightening can be found in the technical tips section of this CD.